Alright class, in this video we're going to be taking a look at how do we answer a question like how much material is needed for a truss calculations like the ones that we're seeing here. And in this case we're not getting too complex. We're actually going to be mostly using Pythagorean's Theorem to go ahead and measure the different lengths of the triangles that we can see, but we don't necessarily have the measurements for. Now, when you're looking at just the technical drawing, you're probably going to be saying there's a lot of information there and you get a little intimidated. And that's expected. You know, you see a lot of information and you figure out, how do I go ahead and approach this? And the best way to approach this, I think, is to go ahead and break it down into similar components. So specifically, we're going to be looking at horizontal lines. We'll look at the vertical lines, the vertical parts of it, and then the two different types of angled lengths that we have. So the C components and the D components. And with what we can see in this chart and the table that's provided, we'll be able to go ahead and piece together all of the different things that we needed. And in construction, it would basically be a cut list, knowing how much we need of each one of these parts. So, to go ahead and move into the problem itself, the first part of this that we're going to break out is we're going to focus on the horizontal lines. Okay, that's pretty simple because we can see that while there are four types of those horizontal lines that we're going to care about, A1, A2, A3, and A4, some of it is already provided. A1, for example, we know that there's only one of them. That is the full width of this truss, and we know that that length is going to be 5.0. And all of these measurements are going to be in inches. So we can go ahead and just keep that as a mental note that we're dealing with inches. But from there, we can then look at A2. Now, A2 is a little bit different. We'll notice that it's going kind of the entire distance from the first vertical line to the last vertical line. And while we do not have any measurements directly below it, switch back to my marker. So we don't have any measurements on the left side anyways that go all the way to the right side of it. But what we do have are a couple of measurements we can use. We know how far the first vertical line is from the leftmost point on this drawing, and we can see that we know where the second vertical line is, the last one. So in terms of a calculation, we simply identify that we are looking for, we are simply trying to identify A2, but we know that that is going to be equal to the 5.3, or going to be equal to the 4.5 inches minus 0.5 inches. Okay. Pretty simple mental math. We know that that's going to be 4.0 inches. And we can put that into our table and store it for our later calculations. The next one that we need to recognize is going to be A3, and we can already see that in A3, in the table, we already know the length, and we can actually see that's labeled right there in the technical drawing. But what's left is figuring out how many times we have that A3 measurement. And you'll notice that we only see one instance of it being labeled directly, but we can see that that's going to be in the triangle that has the hypotenuse of C, and we know that in our vertical lines they all have the same height. So this vertical line is going to be equal to every single one of those. So what we can kind of piece together is that A3 is anywhere we need the base labeled when we have that C hypotenuse. So when we label all of them, we can see that we actually have 4 of those A3 lines, and we already have the measurements, and we're kind of solid to go ahead and move forward with that. Now, to verify it, again, they give us the information. We could use a calculator to go ahead and verify it, but I'm just going to leave it on the paper as that 0.5 inches before we move into A4. So A4 is kind of the same deal in that we don't have a direct measurement of it, but they are labeled every time we see them. We see all of these vertical parts already existing. So we can see that A4, we need to jot down that we have 4 copies of those. Okay, 1, 2, 3, and 4 of them. And then the next step is to figure out what is the length of them. And we approach the length of A4 the same way that we approach the length of A2. And that is figure out where's the left side located at compared to where's the right side located at. And in this case, we have lots of different measurements, and we could calculate any single one of these. We could calculate the one on the left, the ones the right center, the far right. It doesn't really matter which one of those we use, as long as we use one and we stay consistent with the types of measurements. So I'm actually going to go ahead and calculate the third one, just because I want to show that this is going to work the same way, any way that we work. And we can see that it's connected to the 2.5 measurement, and it's going to be connected to the 3.25 measurement. So if we say 3.25, we want the larger number first because it goes the furthest distance, minus 2.5 inches is the other one. And in this case, 3.25 minus 2.5 gives us 0.75 inches. So at this point, we've taken care of all of our horizontal measurements and we're able to move forward. And just as a quick example on the A4, had we gone with the leftmost sides, 1.75 inches minus 1 inch, you should quickly calculate that to 0.75. So our numbers check out and we're ready to move forward into the next step. So we've moved our data across already, so you can see that we have all of those horizontal measurements already moved into this table. So the next step is to figure out how many we need of our vertical lines. Now, this one should be pretty simple. Again, it's not all labeled, but we can determine that the vertical lines stay the same. We simply need to count how many of them exist. So, in this case, we know that we have a vertical line here, 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 and here. Not wanting to mix in the vertical or the angled line, but with 4 vertical lines, we can put it into the table, and we're not even having to do calculations on this one. That's an important concept. You do not always need to get your calculators out for these problems. It's just reading the information that's already provided. So with that recognized, we're able to go ahead and start figuring out what we need for our C components. And this is where we will need Pythagorean's theorem. So as you should remember, a squared plus b squared equals c squared. So it helps to write that down. And notice that the values in this formula are not the same ones as the tables that we're seeing. It's just a coincidence that we're seeing c being c squared. Okay, so using information on our table, we can identify that A is basically going to be the bottom base, B is literally going to be our B line. Again, this is a coincidence that was planned ahead, but we can start identifying which values go in. Okay, so A3 of 0.5 inches goes in as A, plus B. B is actually going to be the 1 inch squared, and it's going to be equal to C squared. So for this case, we need to now break out the calculator and solve this problem. So I'm switching over to a scientific calculator. Those typically have the square root functions that we're going to need to be able to solve these problems. So 0.5 squared plus 1 times 1 is 1. We could square it if we need to, but that's not essential. Figure out what it's equal to. The 0.5 squared times 0.5 squared plus 1 ends up being equal to 1.25, and we need to find the square root of that. So we find the square root, and in this case, C squared equals the 1.25, but C on its own, since we took the square root, again, recognize that we're taking that square root, C is going to be equal to 1.118, or it's approximately going to be equal to 1.12. That's what I'm actually going to put into the table. So 1.12 inches, that gives us our C value, and we're able to move forward into the almost last step. So, as noted, we keep moving the data across in our table, so we can see that that 1.12 was added to our mixture, to our table of information, and what's left is we need to go ahead and figure out what is the length of D. Now we approach D the same way, so A squared plus B squared equals C squared. In this case, we're not using A and B directly. We're having to recognize that A4 is going to get squared, that our value, our unit of B, is going to get squared, and that's going to be equal to C squared. Okay. Knowing that information, we can now pull it off the tables. So A4 was the 0.75 inches squared, plus B, which is 1 squared, equals C squared itself. We need the calculator now to go ahead and help us out. So we clear out everything. 0.75 squared plus 1 squared equals, so C squared equals 1.5625. We know that we're going to want the square root of both sides. We can trust the calculator to do it for us. And we're now told C equals 1.25 inches. We put it into our table, and then we move into what is quickly becoming the last step. Okay? And this is where we need to recognize that just because the table has a lot of information doesn't mean we actually need all of that information. The reason for that is our A1 value, so our A1 value includes everything on the bottom. So A1 equals all 4 of the A3 values plus the 4 A4 values. Okay? So we actually get to ignore that information. We don't necessarily need to include it. It's good that we have it. We're not throwing away information. We're just basically saying, I don't need it for the actual calculation. But what we do need to find the total is that we need to recognize that we have A1 plus A2, that's the top horizontal line, plus our 4 vertical lines. So 4 times B plus the 4 C values plus the 4 D values. Okay. And I like writing out these formulas and piecing together the information because I can make sure that mentally I have everything that we need. Okay. We can see in our table A1 exists one time, A2 exists one time. We established A1 equals all of those A3 and A4 values. We don't need those. B exists 4 times, C exists 4 times, D exists 4 times. We've checked it off. We know that we've got what we need before we start putting in the numbers, at which point 5 plus 4 plus 4 times the B value is 1 plus the C value, well, 4 times 1.12 plus 4 times 1.25. Now we turn back to our calculator. Again, you could do some of this pencil and paper. You could go ahead and just kind of go all the way through it. But we can go ahead, clear everything out. 5 plus 4 plus 4 times 1 plus 4 times 1.12 plus 4 times 1.25. So, piecing it together, we should be able to recognize that we need to have a total material 22.48 inches. Now, keep in mind there could be a couple of rounding errors in there, and if we're actually cutting this out of real wood, real materials, we can only get it in specific lengths, ones that are provided by the store. So we may have some lost material or not have enough to go ahead and fully cut out all of the pieces individually. So always plan a little bit to get the extra material, but that tells you how much you would need for a project like this. And this is something that they really do in construction, manufacturing, and knowing that they have enough material to take on any project that they may be doing. So I hope this helps. I know that it goes through a lot of steps, but this is a good practice problem to kind of work through in recognizing the amount of material you need on a project like this. So, as always, take care. If you have questions, leave them in the comments or messaging me, and I'm always looking forward to finding ways to help you guys out.